So you want to become a command line wizard, huh? Yes, okay. So, yeah, this talk, basically, it's gonna be, sorry? Too quiet?
I think microphone is not.
It's not? Hello, hello? Oh, there we go. Okay. I'm sorry, it's a bit, I'm quite a tall person, so I'm gonna have to lean forward a little bit. So yes, in this talk I'm gonna show you quite a few new command line tools, and in fact, I'm gonna give this talk on the command line. The takeaway is supposed to be, at least, that you know some new tools at the end of this, and you basically don't have to know anything before that. Like, you don't even have to know how to get around any kind of Unix system. One thing to note is that even though I'm going to be presenting many tools and many alternatives to well-known tools, this is not meant to be like that you have to replace your old ways of doing things. It's just like that you can supplant your current knowledge with some new tools. And these tools are mainly meant to be for interactive usage and not so much for script usage. For script usage, you should always kind of use the old tools that you're used to, because they are most likely not going to be available on the systems that you're going to be scripting for. So, with that said, let's talk about me just really quick. So yeah, I'm a command line enthusiast, as you might have figured. I'm an Arch Linux developer. Yeah, and I use Arch, by the way. And I work as a DevOps consultant, freelance. So, why even bother? Sorry, this was meant to be like this. Why even bother with the command line? Yeah, so anyway, so command line is not gonna go away. It's been here for like many decades. It's gonna be here for some more decades. Might as well embrace it. It's efficient for many kinds of tasks. It's not so efficient for other kinds of tasks, but you should pick the right kinds of tasks to use the command line for, right? Or pick the command line for the right kinds of tasks. And sometimes you just can't use a GUI, right? Sometimes you're logged into some servers. Now, me working as DevOps, I log into many servers a day, and basically I really gotta know my tools around that, and you can't always have an X server. It's really not possible. And yeah, text is still the only truly universal exchange format, despite what other people might tell you. And yes, the slides themselves, I'm just gonna go ahead. They are on the command line. Yeah, right. I want to draw your attention to the fact that we have fade-out effects and fade-in effects. Watch this. All right. So, don't worry, you don't have to memorize this. This is just like an overview, because this is essentially a completely live kind of affair that we're going to have going here. So please cut me some slack if something goes wrong, right? Yeah, we're going to be looking at some tools and some common tasks and what you were probably used to, and then what you might be using now. So let's have a look, right? So first of all, exa. Exa is a tool for listing files. Now you might know that you can list files in Unix systems using ls and tree, but exa is pretty by default, and it has Git support. So let's take a look what that means, right? So normal ls looks like this, all right? It's a pretty plain. So my ls looks like this because I have some alias to make it pretty, but usually if you log into some default system, it looks like this, right? But exa also looks like this by default. But now this is not really so fun, is it? So let's, for fairness sake, let's use ls-l and use my, oh shit, this is a bit, I don't want it to wrap. I'm gonna see whether I can you guys see that at the back? Is this, okay, great. And then I'm gonna keep it like this so it doesn't wrap. So, so we can see here what the ls-l output looks like. So it lists my user, the attributes, lots of stuff. It's not particularly helpful though. If you wanna know the real sizes, you gotta do this, right? So that you get the human readable sizes, and everything could be more colorful, right? You could always make it no colorful. Basically, the trend nowadays is to make everything more colorful, and so you got exa-l, and now it's very colorful. You can see here that the attributes are all colorized, so you can easily skim that. The sizes are human readable by default. The users, actually, my user is Twinstaros, so it's like yellowish, and the root user, which is not my user, is just kind of like grayish. And then the other thing is also readable. Now, the way the files are colored is that executable files that have the executable flag on this side here, they are green, so you can see these as green. Multimedia files are like violet and so on and so forth. So there's actually some logic to that. But we can go even further. Now, what if we had Git support right built in? So we have this Git column here. I can actually show headers. So it might be a bit more, oops, header. We have this Git column. And on the right side of the Git column, you have files which were changed locally but not yet staged. And on the left side, you have files which were staged. So we have N for new and M for modified. So this is pretty cool. Alice doesn't really have that. But we also have tree, right? You have this Unix tool called tree, which shows you a file tree. And if you want to have the same in Exa, you can also do like exa-tree. Now it looks a lot like the same, right? It's essentially the same. But can your tree do this? It can. There was a trick question. It can, but you have to do like D. I actually had to write this down. D, P, right? Like that. Not quite as colorful, is it? But now we have seen that Exa can do this. But can your tree do this? No, it can't. And this is amazing, right? You can basically check your structure, and you don't have to alternate between tools like Git status all the time, right? Like that. That's pretty amazing. So that's Exa in a nutshell. Let's continue. FD, finding files. Now, personal pet peeve of mine is like find is kind of sucky, to be honest, in interactive usage. Like if you want to just kind of do something and like make a fuzzy search for something, it's, you always have to put the single quotes at the right location, put the asterisk at the right location. That kind of sucks. Now, but we have FD, which is like find, but it doesn't suck for interactive usage. And it's colorful as well. So you might see a trend here. So let's find all of the readmes in the CPython source code, right? So I have this prepared. So we have find, right? And I have CPython right here. And we want to kind of, because people can, we have to give iname because it might be case insensitive because people might write readmes in weird kind of capitalization. So go like that, and we have to go like this, readme, asterisk, and then we get all the readmes in CPython. Great. So we can do the same thing with find, with FD. Go like this, FD, and then just source CPython. And it's the same output, but a lot less tedious to type, right? If you compare these guys, a bit less tedious to type, and honestly, just nicer to look at because it has colors. But we can go even further, of course. What if we wanted to find all of the Python files in the kernel output, kernel source code actually, right? We can do that. Or actually, let's do something else. Let's find all of the parser files in the CPython source. So we might want to go like this. And we only want to find Python files, so we do like this, right? Now we can do the same thing with FD, like this. You have this -e, which means extension, like that. And then we can do the same thing. Right? But now we can keep adding extensions easily, right? Like that. For instance, we can find all the RST, probably it has RSTs. It has some, you see. And we can keep adding extensions for that, so we can more easily do this. To be honest, I have no idea how to do this in find, because you kind of have to like write a regex and maybe make a subgroup or something. So that's kind of annoying. Another nice feature of find is FD is that it actually uses our git ignore to ignore files that we don't want. So if we look at our git ignore right here, it has some, like there has some little example repo that I did. There's this ignored file, and lo and behold, there's our ignored file. And if we FD for ignore, won't find it. But if we go like U for unrestricted, it will find it. So that's a nice feature, because usually you don't want to search for files which are ignored by your git ignore. So that's FD. Continuing. Rip grep. Now, many people might have heard about that. It's quite a common tool nowadays. It's insanely fast. It's like grep, but it's really, really quick. And it's also user-friendly, and it has amazing colors. And it also uses git ignores. So what does this mean in practice? Well, how about we search through the whole Linux source code? And we search for buffer, right? The buffer word comes up quite a lot with the Linux context. So I'm just going to let it run for a little while, but the general idea is that Linux uses a lot of buffers. And it takes quite a long time. Like it took like 9 seconds, as you can see in my shell there. Let's do the same thing with grep. Oop, there. Oh, fuck me. Hang on. What the hell? Oh, because I copied this. We don't have to provide the recursive flag for grep. It also does this by default. It's quite a bit fast if you see 2 seconds against 9 seconds. But now, grep also does something nice. It ignores binary files by default, which grep doesn't do. And git is basically a bunch of binary blobs, and we don't really need to search that. And also, it has git ignores by default. So we search a lot less stuff, and we usually don't care about all of that stuff. And also, if you check the default way that things are kind of looking, so I have this file here, the API helper, and this is the output for grep, and this is the default output for grep. And you can see here that the output differs quite a bit in the way that we get file numbers. I think grep can do this as well, but this is just like comparing the default output. And by default, grep actually doesn't do any recursive searching, which if you don't do this, like it just kind of sits there and waits for standard input. It doesn't, not very useful to be honest, right? So it might make sense to just search that. So this is what grep does. It also allows you to search for specific types of files. So if we provide the file type py for Python, and we search for buffer in the Linux source code, turns out there's actually some occurrences of buffer in Linux, right? So this is all Linux, all Python files, as you can see, in Linux, which do some helper tasks. So that was pretty nice to do, and with grep you kind of have to find all Python files, pipe that into grep, and that's kind of annoying. So that's grep. It's pretty cool. Next up we have Tokai, or Tokai, I don't know how to pronounce that, but anyway, so it's kind of like cloc. Not many people have heard about cloc actually, but if you want to count your lines of code on the command line, usually you would use a Perl script called cloc. Now Perl is a language engineered to be the slowest possible scripting language. So it takes a long time actually to do anything in Perl, and I can actually demonstrate this by just counting the number of files, the number of source lines in CPython. It takes a little bit of time, but the general idea is that, well, it takes some time, is the general idea to be honest. So there we go. Yeah, it's wrapping, sorry for that, but you can see it counted this. We get some result. Now Tokai, as an alternative, basically like that, right? So it's pretty fast. Tokai allows us to count anything we want, like Linux. Takes a few seconds, but I did this with cloc and it didn't finish when it took minutes, to be honest. We can also see just how many C files there are in Python. We can only count the C files, like T for type. And then turns out there's a few, or sorry, I'm saying files, right? But I mean lines of code, of course. So that's Tokai, short and sweet if you want to count lines of code. It's not colored. I think this is probably the only utility that we have today that's not colorful. Next up, HTTP, a personal favorite of mine. It's like curl, but it's like super user-friendly. You know, curl also kind of was made with the ability to be super user-unfriendly. Like you have to, like, if you actually want to provide JSON or something like, I can't remember the syntax ever, right? But let's try and regress, right? So I had to prepare this because I really can't. So I have this local loopback HTTP server. So it just gives us that, right? So let's do the same thing with HTTP. And for some reason, the command line tool is just called like HTTP, right? I can't imagine this ever conflicting with anything at all. So it looks like that. So this looks much better, right? And this is the same kind of like output, but it shows us the response headers in a nice kind of formatting. It has colors. And then it has it knows it is JSON, and so it parses the JSON and kind of formats the JSON as well, right? So that's pretty cool. And now, for instance, we can also tell curl to show response headers and request headers and everything, and it looks like that. And I'm like, oof. I mean, so these are the request headers because it has these lines going inside, or the arrows going inside, and these are the response headers and the response body. But to be honest, like, so let's use curl to send some data, and I had to write this down because it looks like this. So this is some JSON. And then we can't forget to set the headers, always set the headers like that. And then don't forget the method, never forget the method. All right, and it looks like that. And then you have this, right? And we get this back because it's just like a dummy HTTP server, but you get the idea, right? And this in HTTP is like that. I'm not kidding, it's that simple. Yeah, we can actually also show the request headers and everything in HTTP using show, and then basically it's a bit weird of a syntax, but you get like capital H is I think the response headers, and then the request headers is like the lowercase h, and same for body, and then it looks like that. So I think this is pretty cool, right? You can see that. And you can also set headers the same way, so lol rofl or something, and you can see that we set the header lol rofl, right? So that's pretty cool. Let's continue. Bet. Now bet is an interesting one. Bet is like cat, and if cat and ls had an amazing magical unicorn baby, right? And that's kind of what bet is. It has syntax highlighting support, and it has automatic paging support for long files, and it has Git support. Now, how does that possibly work? Well, I can show you. So, if I just bet something, like change file, you can see that it has these weird things at the end. Or actually, let me show you this. Let me show you this first. So, we have API helper with just a Python program which does something, right? But it looks like that, right? Not very interesting. But then we have bet. It looks like that, and it also has a pager built in. So we have like this, right? So we have syntax support. We have, on the left side, you can see that we have these little squiggles, which means that this line was changed, and I wrote this here, this line was changed. These lines were added, you can see the pluses, and it won't use the pager for short files. So if you just go like staged file, it will like basically just not use the pager. It will also give us line numbers, which is nice. And that's essentially all there is to know about bat. Now, obviously never use bat as compared to like cat or less if you want to use, or actually compared to cat, if you want to actually concatenate files. But if you just want to look at files, right, it's pretty cool. And also, if you bat binary files, it will just say like binary, and cat is gonna be like, yeah. Yeah, so that's that. SD. SD is a short and sweet one. It's basically like set, but people can actually use that without looking up the menu. So have a look at this. We have this change file, and we have this replace me replace. So with set, if you actually want to replace that, we will go like set-i s/replace, and then something, and then g, because can't forget the g, because it will only replace the first occurrence per line, all right? So can't forget the g, and then this, and then change file, and then if we bat this again, see it replace that. But with SD, you just go like something, change it back to replace, and then change file, and that will actually have to change it back. But if you don't want to commit, right? We are a generation of millennials. We can't commit, right? If we go like -p, we can preview that without actually changing the file. So that's pretty cool, right? So that's all there is about SD, which is like set but user-friendly. And then we have hyperfine. Now this is an interesting one. Usually in Unix, if you benchmark things, what would you do? You would whip up time, right? And then just run time a bunch of times. I can actually demonstrate that. I have this taxi simulation here, which is a very fast program that does something, and in theory has some output, but we don't show it. But so if we want to time that, how long that actually runs for, we can run this a few times, and we have some data, but you know, Then we have hyperfine, and now watch this. There's some spawn up time to measure something, and then it basically runs the program a few times to make sure to sort out the statistical errors, and it will actually also take note of the min and max times, and you can see they were actually quite considerable, right? We can actually tell it to run a few more times, but the general idea is that the program runs quite a few times in order for it to figure out how long the program really takes in total, right? And so we get we can execute very quickly terminating programs and still make sure to benchmark them properly. And so now we are down to a delta of like a plus and minus of 10 milliseconds, which is quite a bit still, but at least, I mean, the program terminates very quickly. But you can imagine how this is useful if you want to benchmark some other tools. Right, so, and yeah, you can also specify a warm-up phase if you're into that kind of thing, so where it basically runs the program like a few times beforehand and then completely discards the measurements, so just in case you have some kind of I/O demanding program where you want to be very sure that the thing that you want to benchmark is absolutely your I/O cache, right? So you can do that. It's pretty cool. And now, yeah, we have a bonus because we still have a little bit of time. MDP, which is actually the program that I'm using right now to run this demonstration, which is basically the Markdown presenter. So you write some Markdown files. It looks like this if you want to be very specific. It looks like this, and this is my talk actually, which is run right now by MDP. And it is like PowerPoint, but it has 1% of the features, but it's all the features that matter, right? And it's on the command line, and your PowerPoint can't do that now, can it? We have another bonus, GenAct. So imagine you want to pretend to be doing some work, but don't actually want to do any work. Now what do, right? So you can run GenAct and go like CC, and now we're compiling something. And you can run GenAct-m weblog and pretend you're looking at some really, or I don't know, kernel compile. You get the idea, right? You can also just run it like without any arguments, and we'll go into demo mode and we'll run a few iterations of every kind of program that it has. It has quite a few programs actually. Has these programs, you can run that. So you can do this, all right? I don't know, you get the idea, right? So I'm glad you like it because it's actually the only program in this whole list that I've written myself, so thank you. Thank you for that. Yeah, we have one more bonus, which is a very short and sweet one, ASCII Aquarium. It's just like that, right? You have fish on your command line. We have one more, and then I'm done, which is C-matrix. Probably everybody knows this, but still, for completeness sake. Yeah, thank you for much.
Yeah, thank you very much, Sven, for this very colorful talk. Are there any questions or comments?
Does FD also have a statement like execute as fine?
Yes, it does. In fact, it also has a batch statement for execute. So if you want to get rid of X args, you can do that instead. So it's pretty cool actually. Much less painful to use.
So when you have questions, you can also line up at the microphones on the side.
There was those second signs after your command line, like after master, like 3 seconds and so on. What's that like?
Oh yes, oh my god. Okay, so that's
like 59.
I see. Yeah, so if you run a command which takes a few seconds to execute, after 1 second, my shell will it will always keep track of the command, and it will show you how long that command took, always. So you can't forget that.
And you define it like RC file or what?
It's actually called liquid prompt. It's for Zish shell, and it's
Zish?
For the ZSH.
Yeah,
shell.
Z shell like.
Yeah, for that, and it's like a special prompt which has this thing built in where basically it only shows you what you need to know. You can see I also, like, this is my Git state currently.
It's like almost Z shell kind of, no?
No, well, it's a special prompt for Z shell.
It also works with hash.
Yeah, there's also a bash version of that. It's pretty cool. I can recommend Liquid Prompt.
More questions?
No, I forgot the question.
Don't worry, you can catch me later outside.
Maybe in the meantime you can tell us how this fade in, fade out works.
I actually don't know. I think it uses NZ color codes, but I don't actually know. But I actually wanted to look that up.
The back pager, do you know if it has an option to print to the alternative screen? So when you close it, it doesn't show up in your shell folder?
I see. So this is just a normal, I think, shell feature where you can press Control Z in order to background the task, and then you have this. You can see this one sleeping process here, which is now sleeping, which is my presentation. You can type jobs to see which jobs are currently sleeping. It's just this, all right? And then I can press FG to foreground this again. And that's pretty cool. Oh, sorry. Well, let's. I can show you outside.
Okay.
So, if you're ever running graphics, what kind of window manager do you use?
Well, I use graphics right now. Actually, I'm not really on the command line. I'm actually lying. It's I use i3.
i3.
As you can see, it's just normal A3 stuff, right? I can do this, right?
What terminal is that? Is that?
This is the Termite terminal.
Terminal. Okay, thanks.
Any more questions?
Do you use any other tools related to terminal work which increase your productivity or ergonomics? For example, I think the best tool I found is drop-down terminal. I use Yakuak. Maybe some another tips or tools you use or your work?
Well, so originally I wanted to show off Vim because I also put this in the title of the presentation or in the description text, and I figured we didn't have enough time for that for a whole Vim thing. So I use Vim a lot for everything. Really, I do everything. No, without team. I just use i3 and just keep opening terminals. I don't like the double kind of window management. I know that there's tools to make that easier, but honestly, I like to keep it simple and that just have lots of i3 windows. In fact, I have 10 open desktops right now and all of them full of windows, so I use a lot of windows.
One question here. Is grep faster than Silver Search?
Yes, at least, I mean, so I used to use the Silver Searcher, so the question was whether grep is faster than the Silver Searcher, which is another tool that looks a lot like grep and also has colors and also same defaults. The basic philosophy of grep and AG, or the Silver Searcher, are much the same. It's just that grep just happens to be like 5 times faster in the benchmarks. So makes some difference, I suppose, with very large repositories.
Do you recommend using Tmux?
Well, so I use quite a bit of Tmux, but honestly not for development, more for, well, it looks nice. I don't know. So I know Tmux is very popular with OS X people because they don't have a proper native window manager. I think nowadays they do, but generally speaking, I don't really like window management in Tmux so much as I like it in i3. And I don't want to manage them like in 2 ways.
Can all these apps that you demonstrated be installed with Pacman or?
Yes.
Okay.
In fact, I package most of them for Arch Linux, but also for other distributions and also for Windows and OS X. So they're all available in Brew, I think, and they also all have precompiled binaries for Windows, which just work.
How difficult it is for you to reproduce the same environment on another system?
Pretty easy. I mean, it depends on how much control I get. Since most of these tools that I demonstrated are written in Rust and have static binaries, you can just kind of get the binaries, download them, and they will always keep working, except for HTTP Py, which sadly is in Python, and the distribution is a bit more complicated. I know it's a bit, it's a weird thing to say here, but yeah, Python distribution is still not solved problem, I think. But yeah, it's pretty easy to replicate the environments.
Do you use any other displays like a status bar or anything like that?
Sorry, come again?
Do you use anything else like a status bar or any other kinds of displays?
Oh yes. Well, so I use Polybar for displaying my system stuff, but I like to keep the output to a minimum. Like I'm not into very flashy, conky stats and stuff like that because I never look at them anyway. Just like keep it simple and make sure that the system has enough battery time.
Cool. Very, very much thank you to Sven. Give a warm hand to Sven.